Thank you, Stephen, for that. And as Stephen said, I'm Darren Capes. I'm a fellow of the IET and of the Institute of Highways Engineers. And my day job is Intelligent Transport Systems Policy Lead at the Department for Transport. And I also chair the IET's transport panel. So very strong interest in engineering generally, and particularly engineering around roads and the highway. I think I need to start with an admission, the admission is that I'm not a systems engineer in the terms that you would probably think, in the terms that Cozy would think, but I have a lifetime of experience in transport systems engineering, so building complex systems for managing transport, managing traffic, dealing with congestion in cities, delivering the services that we all expect around transport and public transport and parking and traffic management, all the various things that we expect to work in cities to make transport work. Now, of course, whether you consider it, whether you call it systems engineering or not, that is exactly what engineering transport systems in a city is. It's a case of bringing increasingly complex engineering systems together in a way that is resilient, is safe, is cyber secure, is maintainable, is sustainable in terms of maintenance and operation, and provides the services that people expect it to provide in a safe way. And of course, the complexities around this are only growing. And certainly when I started my career, as a highways engineer, the only interface with the vehicle I needed to know about were the 4 patches of rubber that kept the vehicle on the road. That really was the interface between the highway and the vehicle. Now, of course, we're moving into a period of connected vehicles. We're starting to see increasingly complex linkages, increasingly high aspirations from vehicle manufacturers and owners about what their capability of their vehicle will be, its ability to tell them about their surroundings, tell them about what's ahead, tell them about what's happening at their destination. This is all leading to full connectivity. It's all leading to potentially to autonomous vehicles. It's all leading to ever more complex connected systems that need to be built jointly by the public sector, the infrastructure owners generally, and the private sector in terms of the vehicle manufacturers, the vehicle system manufacturers, mobile networks, app developers, and the whole of the community of people that are involved in this. So I'm afraid I'm not able to be with you for most of the day. I'm really here to give a presentation and then leave you to think about it. And I've kind of styled this presentation in terms of this is more questions than answers. And what I want to do is just talk about some of the challenges with engineering the highway, with engineering in transport networks, particularly in urban areas, to give you some food for thought for the rest of the day, really, to think about some of the real world challenges that systems engineering needs to solve if it is to work in terms of the highway network. So traffic control systems, let's start with a little bit of history just to understand why we are where we are. So traffic control systems have been around for many years now, and there are some well tried examples. The NERTS system, the National Roads Telecommunications Service, is a system that I'm sure the next speaker will be able to speak more about than I can, because it's a Highways England or National Highways system. But it's a self-contained system that allows connection through private communications of a whole range of on-street equipment via control rooms. The urban traffic control system that we generally use in cities is a very similar thing. It traditionally used copper wire, used analog signals over copper pair to connect traffic signals and other equipment via BT exchanges into central control rooms. And these systems have something in common, that they are enclosed, they are closed systems. It's easy to own the system, it's easy to own the whole landscape, it's easy to understand the system's implications of those technologies because they are enclosed. About 20 years ago, we moved towards a technology called UTMC. Now, UTMC introduced internet protocol, internet architectures into traffic systems engineering for the first time. And it allowed us to start to think about not owning our communications networks. It allowed us to start to think about owning remote devices, communicating with remote devices via internet comms, via initially ADSL, but more recently 3G, 4G, fiber connections, and any other connection that can carry an internet protocol signal. Now, of course, this has huge benefits. It has huge benefits in terms of the sustainability of systems, and the sustainability of services, and that it makes it a lot cheaper for public bodies to run complex systems. It makes it much more viable to connect up much wider systems, to automate and to communicate with a much wider range of on-street technology. And as on-street technology increases, as we start to see the implementation of smart streetlights and EV charging points, of wide range use of air quality monitoring, of information at bus stops, the potential for connecting equipment together has long past the point where the public sector could own the network that does that. So UTMC and the use of IP was very important in that. And of course, that also allowed us to connect devices in much more complex ways as well. It allowed us to use standard databasing technology. It allowed a whole range of standard industry technology to be brought into the highways engineering. But it introduced a high level of systems integration. And for maybe the first time in the life of many highway technology engineers, it introduced a need to think about system interoperation, about security, about safety, resilience, about the types of things that are common in other factors. So UTMC 20 years ago started this process and was starting to think more about our systems, not as closed systems that we own from end to end, but as very complex holistic systems with many interfaces in a very complex landscape. That obviously is going to get more complicated. Sorry, I can't advance my slides for some reason. Just give me 1 second. Oh, there we go. There we go. So we're now moving into a world of increasing complexity, increasing cooperative systems. And what we see here is a model for a very high level model for how connected vehicle systems will work. And across Europe, many very clever people, many very clever companies are thinking about this. And the European Commission has been working for a number of years now, since about 2010, on developing regulations for what users could expect, what services we could expect to deliver, what we call the ITS Day 1 and Day 1.5 services, the services that we could deliver if we used fully connected technology. We have aspirations for further regulation around what we call CITS, Connected Intelligent Transport Systems, about very futuristic services that will lead to fully connected vehicles and eventually autonomy. These are all things now that we are grappling with, and we're having to think very carefully about how we build systems to deal with this, how we build systems to deal with the fact that we have increased amount of comms accessible over public networks. We're increasingly relying on comms networks. Increasingly, as we move to services such as 5G, well, the mobile network operators see increasing internet connectivity of things as the main reason driving 5G, not necessarily better phone calls or the ability to share video. It's the Internet of Things. It's increased connectivity that's the driver for 5G, and that's very important in transport because again, that potentially leads to a step change in the number of devices that we see connected. Pretty much every vehicle on the road now, certainly every vehicle built in the last 10 years is likely to have a SIM card in it. Any vehicle built in the last 4 years already has a service called eCall built into it, which will automatically warn the emergency services if you have an accident, if an airbag deploys after the vehicle turns over. This is pointing the way to the fact that increasingly vehicles will be part of the trust domain, part of the domain that we need to understand as highway engineers. And increasingly, we will see vehicles as edge computing devices, and we'll see a huge amount of intelligence there. Now, we've been grappling with this idea of edge computing for a number of years, and we've gone from the state of many years ago using analog comms of basically just using bits to tell devices what to do in real time, to actually trusting devices at the edge of the network to do their own computation, to make their own decisions, and to communicate as and when. Bringing vehicles into that obviously increases the number of devices that could be edge computing, the number of devices in the trust domain that we need to consider. It increases it by factors of who knows what, into potentially millions of devices. Now, certainly across the UK, if you think about the problem that national highways are grappling with, that's a big problem. Certainly for a large city like London, that's a big problem. Even for a small city like York, where I'm sat at the moment, that's a big problem. That's a big issue about how do we build systems that are secure? How do we build systems that are secure in terms of the way that vehicle manufacturers think of security? BMW doesn't want to build cars that are potentially insecure because they're connected to public networks. It wants to have a very high level of quality service, a very high level of security and resilience within its vehicles, but it still wants to share data. It still wants its vehicles to be able to participate in cooperative transport systems. So we need to think really, really carefully about how we build systems that do this, how we use wireless networks, public and private, how we think about connected autonomous vehicles and increasing amounts of computation in vehicles and increasing amounts of reliance on external data sources. And how do we get the benefits from this? How do we get the huge benefits to the city of being able to understand where every vehicle is, of having potentially millions of sensors looking at the road surface, looking at conditions, understanding where congestion and incidents are happening in real time? How do we maximize the benefit of that? Now, this fundamentally, to me, is a systems engineering problem, because it seems to me that each of these systems, each of those bubbles there, works. We can build vehicles, we can build wireless networks, we can build transport systems. We've been doing it for many, many years. How do we integrate them effectively, safely, and resiliently? I don't intend to go through this in any great detail, but I want to leave this with you as a bit of food for thought, really. This is the kind of issue that we're wrestling with. This is the kind of diagram which certainly 20 years ago, even 10 years ago, most people in highway engineering were not even thinking about. And there are boxes on this diagram that 20 years ago people in highway engineering would never have heard of. But this is where we are now. We are into a world where highway technology has to be validated and certified and has to be proved in the same way that other complex systems in other sectors and other industries do. And this is something that's new to the sector. So the question really here is, how do we bring, if you look at the black oblong boxes, the black bordered boxes, how do we bring traffic control centers? How do we bring vehicle manufacturers, original equipment manufacturers, and third-party data centers together? How do we use wireless networks to communicate? How does, looking at the circle on the left-hand side, how does the software and the systems and the technology and the comms that work in the infrastructure, how is that validated to work effectively with the circle on the right-hand side, which is the in-vehicle technologies? Again, there are two completely different bodies here that work at completely different speeds and with completely different budgets. I think it's fair to predict that the budget that City of York Council has to think about this is slightly less than the budget that Mercedes-Benz has. But fundamentally, these become part of the same problem. These become part of the same ecosystem, and they need to work together. How do we start to do that? How as systems engineers do we start to unpick that diagram and provide assurance that we can build systems? And not only that, but how do we do it in a way that allows interoperability across national borders? How do we ensure that vehicles built in Spain can drive through France into the UK and integrate to London and collect all the data they should be able to collect and deliver the services that owners will expect and contribute to the operation of the network as the network operator expects? How do we ensure that level of interoperability, safety, and resilience as we move forward? And this will become increasingly necessary as we move towards increased connectivity, as we move to the increased use of autonomy in vehicles. And I don't mean the fully autonomous level 5 Google pods with no steering wheel. There are lots of levels of autonomy that will be implemented in vehicles before we get to that sort of nirvana state. But each of those will increase the reliance of the vehicle on the infrastructure and increase the expectation of the vehicle operator on the vehicle's capabilities. So dealing with problems like this and sorting this out is pretty essential to how we move transport forward. So we are seeing some good practices appearing. There's lots of good work going on. OEMs have a very good understanding of vehicle security and vehicle systems. They have a very good understanding of the CAN bus, the connected network that operates within their vehicle. And they're starting to understand how to expose data from that, and what the expectations and capabilities of the infrastructure is to deal with that. And likewise, infrastructure operators are starting to understand more about how vehicles work. There are lots of programs happening around Europe, such as C-Roads, which recently ran a trial on the A2 and the M2 in the southeast of England to actually unpick some of this and link operators and vehicle manufacturers together to put real live information into vehicles for the use of operators, for the use of drivers. In the UK, CPNI, the Centre for the Protection of National Infrastructure, and NCSC, the National Cyber Security Centre, have a very strong perspective on this. Suppliers such as Siemens and Swalco are already working in terms of infrastructure in how to deal with this. They're already building systems that start to unpick that diagram I showed you on the last presentation. But there's a long way to go. People understand their own proprietary systems, but there's still a long way to go in understanding the systems implications of how all this ties together. And as government, we have a national forum, the Transport Technology Forum, which I would encourage any of you interested in how we're dealing with these issues to look at. It has a website. If you Google Transport Technology Forum, you'll find it. But this is about providing guidance to local authorities. How do we get the infrastructure providers to understand the challenges that are coming? Again, there are lots of networks, lots of activities out there at the moment. There are lots of areas where we rely on cooperation and infrastructure, where we have security issues that we need to deal with. Mobile network operators have a role in this. Increasingly, we will rely on mobile network operator networks. Increasingly, local authorities will not build their own networks. They will use 5G, they will use fiber, but we will increasingly rely on other people's networks with other people's standards and safety expectations, other people's threat and risk vectors to understand, to be able to build networks and maintain connectivity. We're working through pilots such as UK CITI, which is a European funded project, again, to unpick this, to work out what that looks like, what that whole architecture looks like, of how data, how services are delivered in a complex environment. And OEMs, the vehicle manufacturers, are trying to work out what the trust model looks like, how they're linked to the infrastructure, what's trusted and what isn't, how they deal with potentially unsafe, untrusted networks, how they maintain their vehicle integrity while that vehicle roams between the different public infrastructure networks that it maybe doesn't fully trust and fully understand. And how does that work? How do we ensure that services are maintained in a very variable trust domain, a very variable trust environment? And again, that's very key, because again, this plays back to the very original point. In the old days, when we could own the entire network, it's very easy to trust the network. We're now in a situation where we don't own the network. We don't really understand as individuals the full capabilities of all the elements of the landscape we're in. It's very difficult to maintain a consistent trust domain around that. And that imperfection needs to be understood and dealt with. So nobody's leading this, but we have some activity going on. We have things such as the Transport Technology Forum, which I've mentioned, which is helping all the 152 highway authorities in England to start to think about this. Now, I think it's fair to say that most authorities in England have a very weak understanding, a very weak capability in systems engineering, but that is something that's going to have to change, and that's something that we're going to have to deal with. The Dutch have built a system called Talking Traffic, which is a national system delivering many of the services that we want to deliver. So that provides a huge exemplar for us to use. We have a number of pieces of guidance. Now, again, I'm not going to go through these, but the slides will be shared. Please look at those pieces of guidance. That kind of gives an indication of where we are in thinking about some of these problems. But it's very much the case that more work is required. And this is very much work in progress. So that's the challenge I want to leave you with today. That's the challenge I want to set for you to think about. That is me as a policy lead in this area. That's the kind of problem I need to fix. That's the kind of thing I expect systems engineering to help me deal with. That's the real world problem that we are looking to solve today. So thank you for that. Thank you. Right, the next question is, can I unshare my screen? Yes, I can.
Okay, thank you, Darren. I haven't seen any questions pop up in the chat box, but I've got one or two that maybe you can help us with. You mentioned that work has been done on establishing what services are required in the future, or might be required in the future. I'm keen to find out more about that. Has that been published or anywhere, or is it available?
There is, and I'll put something together to circulate in the follow-up to this meeting. There is an ITS directive from the EU, and if you want to look at that, that's directive. I think it's 2040/10. I'll confirm that. That sets out the basic services that users should expect around safety, around the vehicle connectivity. It sets out a number of safety cases, such as detecting stopped vehicles, as detecting accidents. It detects services such as you should be able to tell ahead of hitting a toll road what the toll levels are. It sets a number of services that Europe wanted, and that's set the basic challenge that engineers need to solve. The basic set of services that Europe expects vehicles to be able to provide now, and then with the CITS regulations that are following in the future. Now, I'll circulate that, and there are some really quite interesting nuggets in that you can look at.
And has the UK adopted that directive? Are we still following it?
We are, although we've obviously left Europe, we are fully following that guidance, because apart from anything else, it's just very sensible. It's a very sensible thing. It's a very sensible set of services. The other thing, of course, is that although the cars that we drive may have the steering wheel on the correct side, other than that, they are standard European cars. We can't really expect anything other than that. So the services that are offered across Europe, and of course, many people still travel across through the tunnel and over on ferries. Vehicles have to be interoperable to be sold in this country, and they have to be interoperable to operate around the mainland of Europe. So yes, we are very much still adhering to that, and that's likely to be, we don't know how yet, but that's likely to become adopted into UK legislation and guidance as we move forward.
Okay, we have got a question that's come in from Lilanthi. To what extent has the UK efforts exchanged knowledge with Australian efforts in this area?
we meet them every week. No, seriously. Behind all this, and I didn't want to go into this, but behind all this, we have the Transport Technology Forum. We have a body called ITS UK, Intelligent Transport Services UK, which is a trade body that links through a body called ERTICO, which is the European trade body, interest body in this area. Ertico is part of an international corporation of regional bodies. There's a whole network of bodies which are trading information in this area. And we meet for a yearly conference. We have a yearly event called the ITS World Congress, which this year will be live again, thankfully, and is in Hamburg. That allows us all to get together and share. But I think it's fair to say that the UK has driven a lot of the standards that Europe have adopted, and the European standards are probably as advanced as anything that we have anywhere in the world. And I think that the way that the UK is working, the way that the Far East is working, the way the Americas are working are very similar, slightly different, but very similar, but often driven by the work that's happening here in Europe.